Welcome everybody to the Daily Space Weather. Smash here coming at you from the Smash News Network, least busted name in news. We've had no less than 11 M-class flares between December 14th and December 15th. We've returned to levels of solar activity that we haven't seen since July. So exciting stuff going on. Here are some of those M-class solar flares in 94 angstroms from SDO. We've also got the SDO magnetogram for you here. Those flares came from this sunspot group down here in the southwest. You can see how magnetically complex it is. Those magnetic fields very close to each other, very well defined. So let's go around the horn. Here's the southeastern limb, coronal hole rotating in there. Also, you can see a CME happening in the upper left. Couple of CMEs there. We'll get to those a little bit later in the video, let you know how they are directed. In fact, let's switch right now. I forgot to include one of those, so let's put that up right now before I forget, since it's around that same area. You can certainly see some high-speed CMEs happening. You can even see an indication that the Soho LASCO C3 got hit by relativistic particles there. And we'll show you some more detailed views of that a little bit later in the video and give you some ideas of if those CMEs, coronal mass ejections, are earthly directed or not. Next, the northwestern limb, some fantastic filamentary activity going on up there. Got to cover that since we bring the most detailed imagery of the closest star you'll find anywhere in the world. And of course, the money shot, the southwestern limb. That sunspot is now performing quite highly, producing lots of solar flares. If you enjoy the content, support us with clicks. Visit smashomash.com. It's the official website of the Smash team. You can find links to our social media sites, etc. on the homepage at smashomash.com. Congratulations on realizing the channel exists. We're frankly surprised to have any of you here. So help us out with clicks. You can find a link to SureMed there, the Hemp Lucid shop, the YouTube page, Twitter, etc. Don't forget to press like and subscribe if you enjoy the content on YouTube. Don't forget to check our playlists. If you haven't done so, press that share button, press comment. Don't forget to listen to the 12 Days of Smashmas. If you haven't, our record label is called Golden Cat Productions. There are more tracks than that there as well, but the 12 Days of Smashmas are our latest 12 releases. We released a new track on each of the first days, each of the first 12 days of December. So thanks to our YouTube subscribers for tolerating the pathetic censorship on the platform. To our BitChute subscribers, you ought to join us over on YouTube. You're missing a lot of content. Next, we've got some imagery from Cotopaxi here. Lenticular cloud formed over Cotopaxi as gas was emitted. So a great imagery there from Cotopaxi, the glacial mountaintop volcano. It's a noob lenticular. Let's see what else is erupting. Subanose Jima tops the list with a 6,000-foot ash plume. Krakatoa has produced another Volcanian-style eruption there. Krakatoa, one of the best names ever for a volcano. No major ash plume produced from that eruption. Semeru exploding, flight level 140 over Semeru. Popocatépetl exploding, flight level 210 over Popocatépetl. One of my major bucket list volcanoes, as it is a highly active volcano not so far away in central Mexico. Fuego in Guatemala exploding, flight level 180. Nevado de Ruiz exploding, flight level 200. That's a 20,000-foot plume of volcanic ash. And there's Cotopaxi's breakdown. Feel free to pause the video to read that. Thermal images showing up there at Cotopaxi as well. Sabancaya saw an intermittent puff, and Villarrica featuring some elevated Strombolian activity. Please remember, folks, don't pole vault the caldera. The alert zone remains at yellow with a 500-meter exclusion zone around the main crater. Next, we'll look at seismicity, and the largest quake of the past 24 was a 6.3 in the Rat Islands. of the Aleutians. There is the historic data for that 6.3 magnitude quake. You can see it's in an area that is quite seismically active. That 6.3 came in at 1840 Universal Time yesterday on December 14th. So we're just going to scroll up the list here. We did have a 4.9 magnitude quake in the Cascadia Fault Zone off the coast of Oregon. And we're just going to scroll up the list here as the number of earthquakes haven't been very high, just some higher magnitude earthquakes. Not a huge frequency of earthquakes. Myanmar did have a 5.0. Taiwan had a 5.9. We also had a 5.1 near Macquarie Island in the Southern Ocean there south of Australia. Also, South Sandwich Islands had a 5.2. And let's get back to space. It's what is going on. Some major upticks here in solar activity. So we're delighted to see that. And we're delighted to see all of our viewers who are likely tuning into this video as solar activity defines how many people watch the content. Of course, there's always something to talk about. The question is there anybody able to see the videos? The great thing about talking into the abyss is that you know there's nobody looking back. The 10.7 centimeter radial flux has improved to 165 solar flux units. Or maybe it's not an improvement to you. Maybe you're hoping for less solar activity for some strange reason. But in any case, it's gone up to 165. A level that we have not seen since July 18th. So that's the 1-year graph from Solon.info. Again, highest radial flux since July here. Let us know in the comments if you think it's going higher or if it's leveling off at 165. At the moment, the sunspot number has exceeded the radial flux. As you can see, this red line here crossing over there. And that has not happened since July either. So big uptick here in solar activity. The Space Weather Enthusiast dashboard not forecasting any space weather storms, no geomagnetic unrest, as you can see here for the next 3 days. NOAA thinking it's going to be pretty calm. I would tend to agree with that. Let's take a look at Earth's geomagnetic moment from space for the past 4 hours. Things quite calm indeed out there. It is geomagnetically calm conditions. We've seen a coronal hole high-speed stream subside, an increase in the electron flux, which we will get to later in the video. And thanks for leaving a comment. General disturbance. We appreciate those who recommend us. It has been futile for most of our viewers. Next, Earth's magnetic moment from the ground. The last 4 hours of ground magnetic perturbations. We show it daily on the channel, whether there's activity or not. A lot of people are very frightened that the Earth and Venus are going to switch places in orbit or something like that, or that the galaxy is going to kill them, so we show this data daily. 4 hours, Earth's magnetic moment from the ground magnetic perturbations map. Let's let it play all the way through. By the way, in related news, we will be bringing the cosmic ray report tomorrow. We would have done it today, but there's been too much flaring activity and too much great footage to show the closest star. Cosmic ray report coming tomorrow. And let's continue on. The reason people love catastrophe news is because they want the world to end, because they're so sick of the pathetic decisions made for the past 3 years. The planetary K-index is at 2. Once again, thanks for commenting, General Disturbance. Planetary K-index at 2. Certain types of stress and trauma make people misanthropic and fatalistic. That's what happens. KP2, geomagnetic calm conditions. Let's take a look at the real-time solar wind next. We did just recently see some kind of a strike happening here, some kind of a change happening there in the solar wind speed, maybe a minor CME impact. We do see some signals happening earlier today also indicating the possibility of some minor CME impacts, just a little diffuse high-speed solar wind interspersed there in this more steady signal at about 360 kilometers per second for the solar wind speed. Currently a little elevation happening. Also, the BZ just shifted into negative territory. You see that top pane where it says 6 for the BT, the white line. -3 for the BZ, the vertical component of the magnetic field. Current conditions are for the solar wind density, only 2 protons per cubic centimeter. Solar wind speed about 390 kilometers per second. Let's move to the magnetic information. There is the GOES magnetometer for the past 3 days. That is the GOES 16 and GOES 17. And next we'll look at the top view ecliptic plane field plot, because we do have a North Pole current sheet likely headed this way. Looks like it is stalling a little bit, perhaps an indication that we'll see some activity in the northern hemisphere. Let us know in the comments if you think we'll see sunspots degrade in the southern hemisphere or additional sunspots form in the north. Based on this information, that is a forecast we can accurately make because we understand how to read the data and forecast solar activity on the channel. So, are you expecting a sunspot in the north or a reduction of sunspots in the southeast? Let us know in the comments what you think, and let's move to our line of sight field plot. Solar polar fields shown here in red for south, green for north. And once again, we've got North Pole-oriented coronal holes rotating in. So let's switch to our coronal hole view here. You'll see some green here rotating in from the east, and some well-defined coronal holes of both south and north pole orientation here on the Earth-facing portion of the solar disk. So here's your North Pole coronal hole, right up here in the northeast. That is North Pole. This one down here is South Pole oriented. Another reminder that there is a long way to go before we see the solar polar fields reverse, which means solar cycle 25 is barely getting started, folks. There is a lot more activity to come. Don't worry. Let's move to sunspots, something that apparently all of those grand solar minimum enthusiasts have just overlooked, as they've been calling for years for all kinds of zero sunspot days. How's that working out, folks? Speaking of which, let's move to our sunspot view. So, new sunspot named here as we forecasted yesterday. It's 3168. Likelihood of additional solar flares, very, very high. The likelihood of an X-class flare goes up as sunspot 3164 approaches the limb. Shown here as active region number 7, and you can see showing very high there, over a 50% chance at some points there for an X-class flare. Also, NOAA forecasting, that's actually NASA forecasting here the likelihood of major flares from this sunspot as well. At the moment, we've seen all the activity coming from 3164, active region number 7 here on this imagery. So here's some composite imagery. This is the SDO magnetogram plus 193 angstroms. Here we've gotten rid of the 193 angstroms and switched to SDO continuum. Most of those sunspot groups pretty stable here over the past 24 hours, the length of this video. And here's a close-up. Fantastic imagery there. And we haven't seen any relativistic particles despite all of those large solar flares. So the proton flux here remaining flatlined. Check out the X-ray profile. Look at the increase over the weekly basis. Massive increase there in the X-ray profile. The sun right now is at like a, I'd say like a C4 level, maybe a C5 level background based on the last 24 hours. 11 M-class flares. 1, 2, 3, 4, 5, 6, 7, 8, 9. 11 M-class flares between December 14th and December 15th so far. Again, the likelihood of X-class flares rises. Fun fact, those solar flares also attenuate the D layer of the ionosphere, causing radio signal attenuation, or causing the ionosphere's attenuation to send that signal into space instead of refracting it back down to the planet. That's what causes those radio blackouts. Keep in mind, folks, solar flares, that is X-rays, cannot be detected from the Earth's surface. They are filtered out by the mesosphere, and they do cause radio blackouts. So all those M-class flares caused lots of radio blackouts. Of course, most of those occurring south of the equator as summer is approaching for the southern hemisphere. And there is one of those M-class flares. You can see nearly complete radio blackouts showing up there at certain portions of the bandwidth range. Certain portions of the frequency range, I should say. And you can follow that yourself on the Space Weather Prediction Center if you like. The attenuation of the ionosphere caused by solar flares. So, the activity is really going on in the southern hemisphere. There's a composite of that. 94 plus 131 angstroms. And how about some money shots? There are those two wavelengths in close up. And we'll subtract the 94 angstroms here also to show you just 131 by itself. Thank you, SDO, for additional top-notch level images of the closest star. And thanks, viewers, for stargazing with us, where we cite fact after fact, which is probably why we can't get to 3,000 subscribers on YouTube. It's very controversial to say facts because, hey, it's 2022, folks. It's nearly 2023. Is it going to be even more controversial to state facts in 2023? That is the real question here at the Smash News Network. Least busted name of news. Let's take a look at what's going on over our heads in Lehigh Valley, Pennsylvania. That's what's going on. Mars just setting, the moon high in the sky as it approaches new moon. Let's take a solar system forecast. Keep in mind this imagery is not to scale. Earth is nowhere near that close to Venus or to Jupiter, by the way. Here's your 1 week forecast for the solar system. In 7 days, we'll be only one day away from the next new moon, and only 1 day into winter. Only 6 days of autumn remaining for the northern hemisphere. And let's take a look at coronagraphs since we've got a number of coronal mass ejections to talk about. So that is yesterday's imagery. That's 84 frames. We'll also show today's imagery so far. There is December 15th also. And are they earthly directed? Well, the answer is, in short, no. So here's some more imagery from Stereo A located at Lagrange 5 and the SOHO LASCO C3 located at Lagrange 1. We've paused here at 1438 for the Stereo A and 1430 for the SOHO LASCO C3. Now, for a CME to be directed toward Earth, folks, one thing that is for sure is that it would have to be on this line. Earth would be off in that direction from Stereo A's perspective. So do we see any ejecta headed down that line? We do have some on the far side of the sun, which can make it very deceptive and look like a halo when it's actually not, but I don't even think that's going on at the moment. We do have a CME actually propagating as we make the video. So let's just let these play through here. Keep in mind they are different time frames. And you can see relativistic particle strike happen there. We're going to bring that back in a minute. That certainly did look like a direct strike on the SOHO LASCO C3 there. And it was right when some CME material happened. So it looks like there certainly were some relativistic particles right there, as that is right when a CME is propagating. So that is likely actually a good signal there, in that we see a major relativistic particle strike on the aperture. You'll also be able to see that in our 24-hour videos. So let's bring those up. This is the last 24 hours. So at least some very, very high-speed particles there approaching the speed of light, striking the SOHO LASCO C3. You can see that happening there. We'll zoom out even farther, which will show you even more of that. Next, let's look at filaments. Once again, thanks for leaving additional comments. General disturbance. So looking at filaments here, we've got a new segment of the video here coming up. It's called Name That Filament. So what we're going to do is we're going to bring up the last image, and we're going to post this to Twitter. By the way, follow us on Twitter if you'd like to participate in such things. It's the Name That Filament. It's not a contest. It's just to name the filaments. Let's start that up again. Massive number of filaments here on the Earth-facing portion of the solar disk. Huge ones in the east. Huge ones at the North Polar region and South Polar region. Likelihood of additional coronal mass ejections remains at nearly 100%. That imagery from the ground-based solar observatory at Cerro Tololo, Chile. We'll do our best to frighten you with something later in the video. Don't worry, general disturbance. We'll figure out a way to spook people. We'll figure something out. I'm sure there's something to be frightened of. Again, follow us on Twitter, where the pathetic censorship continues. We've got 337 followers and 18,000 tweets, dating all the way back to 2019, March of 2019. And we've got 337 followers, despite daily original content, our own websites, and 18,000 tweets. If you think the censorship is gone from Twitter, I don't know what fantasy world you're living in, but it's not Earth. Milky Way Galaxy team for the win. Next, the last couple of hours of activity here from the GOES 16 SUVi, and you can indeed see a CME propagating right over here as we stream the video live. By the way, we were correct over and over and over and over again about COVID since January 23rd of 2020. If you don't believe me, go ahead and check out the smashomash.com/forum. There is a thread in the Free-for-All forum. We've followed the news updates and copy-pasted articles directly to host on our own servers for over 6 months. Next, the last 24 hours from SDO 304 angstroms. A classic wavelength ionized helium. Great at showing filaments. Great at showing solar flares, of which there are a lot. Which brings us to the border of our bonus features. So here's our bonus features segment. We do have some minor satellite charging hazards caused by low-energy electrons building up on the surfaces, moving into the Central Pacific Ocean here as we speak. Those are, again, minor charging hazards. Here's the GOES electron flux for the past 3 days. Dropping down a little bit here, surprisingly. Maybe see a little bit lower than expected electron flux levels. Those are measured by the GOES 16 and GOES 17 from their geosynchronous orbits using radiography at the F layer of the ionosphere. There is the forecast model from NOAA. There's the one-year chart to put the relativistic electrons in context. And next we'll show the F layer itself, the vibrational frequency of this bridge between Earth and space. It's the 300-kilometer slice of the atmosphere. The F layer of the ionosphere. The layer that is higher up than the D layer. By the way, we are seeing continued indications that the South Atlantic anomaly has recently moved. Maybe that's something to be frightened about. So let's look at the anomaly gram here. That was the raw vibrational frequency. This is the anomaly in megahertz from a 30-day median. And we are seeing evidence here that the South Atlantic anomaly has moved into the South Pacific. So not more than a few months ago, it was located here in the center of the South American continent. It looks like it may have moved, interestingly enough, to the location indicated there. And you can see reasons why we would think so, because you can see these ongoing locations in the anomaly gram there that look just like the South Atlantic anomaly, which does not appear to be over South America anymore. So that's kind of interesting, I would say, for sure. Wasn't really expecting to see that, but that's what happens, folks. You got to cite the facts. Let's let that play through one more time here. Right in this area, you'll see indications that the South Atlantic anomaly has moved maybe 600-800 miles to the west, and even a little bit to the south, I believe. So in any case, That is what's going on. Major ionospheric anomalies happening there in a completely unexpected fashion. So here's the latest image. That's 11:30 Universal Time ionogram. There's 11:45 Universal Time anomalygram. Right there, you can see where that major striation is happening there. That looks like the South Atlantic anomaly, and it looks like it is now in the South Pacific. Next, moving to the total electron content. This is the free electrons between your GPS satellite and your handset, showing you the most likely places for GPS errors. That's the total electron content by Australian Government Bureau of Meteorology still map. And here is the animation. Maybe this won't get as organized as we thought. We've still got huge GPS errors happening over North America, for example. Also over Antarctica at nighttime. So lots of GPS errors. We'll let that play through one more time. We've got a lot of refraction from free electrons of GPS signals. So those are the free electrons between the inner portion of the outer Van Allen belt and your handset. Those GPS satellites are at about 12,500 miles of altitude. So here's your latest intensitygram and latest solar magnetogram. Of course, we can't resist looking at this sunspot group. It is beta gamma delta class. It's got very well-defined sunspots of opposite polarities right next to each other, as you can clearly see there. Such as right here, where you've got a north and a south pole oriented umbra very close to each other. That is the formula for major solar flares, and once again, as it approaches the limb, it's becoming more likely to produce major flares, not less. So don't be surprised to see an X-class flare coming from that, maybe even multiple X-class flares. Also, this group is quite magnetically complex and quite large. What the hell? There we go. So that's beta gamma delta class also. Once again, you can see very close opposite polarity magnetic fields there, which is indeed the recipe for large solar flares. And it's time to move to meteorology, but first we would recommend that all of our viewers become members of the Smash Team. Help support the channel by subscribing to the Smash Team site. The silver membership is only $2.99 a month. The gold membership is only $9.99 a month. You'll get additional content. You'll help to support the channel. You'll be in a credit crawl by the end of the year. So help us out that way. Thanks to everybody who has. The executive producers known as the Smash Team at the gold and silver level. There's also a bronze level there for those of you unwilling and or unable to open your cobweb-encrusted wallets and send us a few bucks per month. Because again, we make just this side of nothing to put the content on YouTube, probably because of the pathetic censorship of big tech organizations. They don't like citing facts, and I don't like doing anything besides citing facts. I'm not a fan of anything. I'm not a fan of your channel or your favorite sports team. I'm a fan of facts and the truth, because to be a fan is to be fanatical, and that is not something that is a thing with respect to me. You can also see, of course, at smashomash.com/smashteam, you'll see the Twitch feed there. So that's what's going on. Thanks again to our Smash Team members. Smashomash.com/smashteam. We still are on Patreon also if you want to support the channel that way. Again, credit crawl coming. You can also find links on the Smash Team page to our Hemp Lucid shop, so check that out if you haven't. You could still perhaps fill some last-minute Christmas orders with some fantastic high-quality products from Hemp Lucid. Thanks to everybody who's picked up products from there. Thanks to Hemp Lucid directly, our latest sponsor/affiliate. We think the products are splentacular, and obviously lots of other people do. There's the most popular, the water-soluble CBD tincture. Tastes great, less filling. Also, check out our merch link. You'll find it on the homepage at smashomash.com as well as below this video. If you do click on that, you'll find the products in order of best selling. I don't know why I'm unable to scroll smoothly. I'm about to smash this mouse with a sledgehammer. All right. So there are the products in order of best selling. The most recent turnover has happened there. The pole vault, do not pole vault the Caldera merch has now surpassed the previous top seller. go back to the top. Oh my gosh. I'm about to throw a computer through the window. So there are our top sellers, interestingly enough. Yes, there are words there that shall not be mentioned because the video is going on YouTube. Yes, the pathetic and putrid censorship continues, including on Twitter. It's not fixed at all. Today's featured product is do not pole vault the caldera. No matter how pathetic the censorship gets, don't pole vault the caldera. If you're visiting a volcano, a volcanic vacation, leave your vault pole at home. So adding a little bit of levity here. Remember, folks, if you're going through hell, keep going. Don't become fatalistic. Don't become fatalistic and misanthropic. It's a very antisocial thing to do. And, yeah, our finest days lie ahead. So that's our message. Our finest days lie ahead. Civilization's not ending. Sorry. If you're frightened because your business model will collapse if civilization does not end, you should get a real job. Speaking of which, here's a quote from Ben Davidson. Kat and I both left 6-figure jobs to pursue our passion. 7-figure jobs. Through grifting. Anyway, even if you've been grifted, don't pole vault the caldera, but do pick up the merch. Tell your friends and foes about it. Thanks to everybody who's done so. Give Smash staff a raise by picking up some merch. And what we're doing now is we're looking at the temperature at the jet stream level. So you may have heard a lot of talk about things like polar vortices and things like that. So let's take a look at some polar vortices here, because what we're talking about is the jet streams. Because what happens is, folks, if you get a hot spot, let's say you have a hot spot, say right here, it might cause the jet stream to shift toward that hot spot, because that is an area of less resistance. A hot spot is effectively a low pressure. So what that does is that's the path of least resistance for the wind to blow, and so that warm air can cause the jet stream to be kinked. This is what people mean when they say it's so hot that it's cold, because the Arctic jet stream, when it shifts, this cold air right here is more massive than this warmer air over here. And that does indeed cause the jet stream to shift because the system is trying to reach static equilibrium. So anyway, those are the temperatures at the jet stream level. So let's take a look at the Pacific here as we've got some big kinks in the jet stream. And let's just switch this to the raw wind data so you can see the way that works out. So there's the raw wind data. And once again, there's temperature. The weather, it's not that mysterious if you understand basic atmospheric physics. So continuing on here, this is the jet stream scenario for the eastern world. Shout out to our viewers from all around the planet. These are the surface winds of the east side. Powerful low here, west of Kamchatka. Next, surface winds of the western world, looking like this. We got a strong low still hanging out in the North Atlantic. Jet streams looking like this. Huge bends in the jet stream here over North America. Also, a 180-degree turn there in the South American portion of the jet stream there. Check it out, this huge bend happening. That counterclockwise rotation, an indication of a high pressure zone. So there's an upper level high, a great example of an upper level high. Those do indeed rotate counterclockwise in the southern hemisphere. Jet streams of the central world looking like this. Huge bends in the jet stream happening there south of Africa as well. Here are the surface winds of this side of the planet, and let's blast through the rest of this video. We don't want it to be too lengthy. We just want it to be chock full of facts. Because that's how you get shadow banned on social media, by citing facts. So here are the clouds and fog over the Americas. Remember, folks, no good deed goes unpunished. You too can create a YouTube channel that stagnates in followers by citing facts on it. Also, perhaps, I don't know, maybe have the best coverage of space weather and imagery of the sun anywhere in the world. That's a great way to have a highly limited channel, right? Dear Big Tech, maybe stop misleading investors. This is what's going on with clouds and fog over the U.S. So here's your weather.gov map, and we've got winter weather advisories over a large portion of the Northeast there, including some hard freeze warnings and more. There's your key. If your county or waterway are lit, click them on weather.gov. And since we've got so much winter weather coming through here, let's do a forecast for total accumulated snow depth. So this is your total accumulated snow depth based on the GFS model for the next 72 hours. You can expect that to be fairly accurate there. There are some differences in the Euro model. We'll look at the Euro model here in just a moment. Again, that's your 72-hour GFS total accumulated snow depth change in inches. Here's your basic, we're going to go to basic pressure and precipitation. By the way, this is all from Tropical Tidbits. If you want to check it out yourself, we use the forecast models on the regs on the channel. This is your pressure and precipitation map. Again, some heavy icing expected for portions of West Virginia, Maryland, Pennsylvania, and New York. Once again, that's a 72-hour GFS pressure and precipitation forecast. And let's move on here to our European forecast for snow depth. So let's advance this here. This is the European model for snow depth. That is Sunday at 10 a.m. Eastern Time. And you can see, once again, the Euro model, just like yesterday, showing the Pennsylvanian snow here shifted a little bit farther to the north. Euro model showing a little unlikely to see significant snow accumulation here in Lehigh Valley, Pennsylvania. Let's continue on to our lightning mapper, and we've got some heavy lightning here in the past 10 hours around the Gulf Coast. Approaching Florida, it looks like some severe weather. And let's take a look at the real-time lightning map to see what's going on in terms of terrestrial strikes. We do have landfall likely coming here. So Tampa, you're kind of in the crosshairs. There is a huge thunderstorm to your west. Heavy lightning there in the Gulf. And if you're on a tall building in Tampa or Clearwater, why not take some imagery, take some videos of that storm? You may see some sprites or other funky activity going on above the thunderheads. Use your phone camera, your digital camera, to take imagery of that, because like the aurora, sprites and red elves and green moons and purple clovers and blue diamonds are best imaged with your digital camera, as there are wavelengths there invisible to the human eye. So take some video of that if you have the chance. Lightningmaps.org is where we are using that real-time lightning map from. Last but not least, here's our radar, shortwave radiation, and water vapor map for the U.S. As precipitation continues to strike southern Alaska, we'll be focusing on the lower 48 for the remainder of the video. Huge band of moisture here stretching all the way from Tampa to Winnipeg, engulfing Pennsylvania as we speak. So here's your shortwave radiation map showing clouds and fog. We got this low pressure here just hanging out off the coast of Nova Scotia. Huge band of moisture here. This low has now moved up toward Illinois, and it's moving into Wisconsin. So Wisconsin's got some low pressure coming. Here is your water vapor map. The low, very obvious where its location is on there as well, as it moves from Iowa into Wisconsin. Here's your recap. U.S. Doppler radar map. The most severe weather there having just left Atlanta, moving towards Charlotte now. Charlotte and Raleigh, you look like you're in the crosshairs for the heaviest weather there. Here's your shortwave radiation map showing clouds and fog. And there is water vapor. That should clear things up. If your Doppler is looking a little bit unclear, we've got this huge mass of dry air right here, providing some impulse and sort of moving that system to the northeast. So that's about where we'll have to close things out. Thanks for tuning in to the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.